All right, let's just jump right into it. Welcome to the crash course. Think of this explainer as a high-yield study session designed to completely upgrade your software engineering habits for 2025. We're taking years of industry research, academic papers, and those battle-tested engineering guidelines and condensing the whole shebang into the absolute most critical habits you need right now. Whether you're prepping for a major career leap or you just really want to drastically improve your daily workflow, consider this your ultimate exam review.
So let's kick things off with a quick pop quiz to kind of challenge how you currently approach your daily work. Think about your very last commit. Be honest, were you just trying to shove a feature out the door to satisfy a ticket for today? Or were you genuinely thinking about how that code is going to perform, scale, and be read by your teammates a year from now? The tech landscape is shifting so incredibly fast, right? With AI assistants and these wildly complex cloud architectures becoming the baseline, the habits that got you here, well, they aren't necessarily going to get you to that next level of engineering excellence.
Here is your syllabus for today. We're covering 5 core modules: the senior engineering mindset, core clean code principles, managing technical debt safely, collaboration and code reviews, and essential tools and debugging. Grab your notes, let's go. Module 1, the senior engineering mindset. We have to start with the inner game, because that massive mindset shift is required before you can really level up.
You know, there's a really stark contrast in problem solving here. The biggest difference between a junior and a senior developer actually isn't years of experience. It's that juniors focus heavily on executing and solving really well-defined problems. Seniors, on the other hand, they step back. They ask the hard, sometimes annoying questions. Like, wait, do we even need this feature? Or is there a vastly simpler way to solve this? They shift from just executing code to framing the actual problem and looking at the system architecture. They absolutely have to know why they're writing the code and how it impacts the overall big picture.
If this were a grading rubric, passing the test relies heavily on your autonomy and your soft skills. Seniors don't just sit in a corner and write code. They leverage communication, they mentor others, and they relentlessly prioritize code readability for that poor developer who's going to inherit their work a year from now. And listen, experience teaches us that mistakes are completely inevitable. But highly effective engineers, they embrace them. They see mistakes as rapid learning opportunities rather than something to panic over.
Moving right along to Module 2, Core Clean Code Principles. Because let's face it, all the mindset in the world doesn't matter if your codebase is a tangled mess.
So writing clean code is going to require a slightly higher initial investment from you, for sure, but man, it pays off because it is literally the only way to prevent skyrocketing maintenance costs down the line. When you write clean code, the cost of making changes stays relatively constant over time. Conversely, quick and dirty programming might feel super fast and cheap on day one, but that cost sharply spikes as technical debt piles up, and eventually that completely kills your ability to respond to business needs.
Consider this rule a guaranteed question on your daily exam. Make a deliberate 5-minute micro-improvement on every single commit without actually changing the behavior of the code. This is the classic Boy Scout rule. It means renaming a vague variable, or maybe extracting a messy repeated condition, or replacing a magic string with a proper union type. If you have 5 engineers and each of them makes 1 micro-improvement per commit, you're looking at hundreds of improvements a quarter. The constraint is key though, less than 5 minutes and absolutely no behavioral changes. It compounds silently until the code base simply doesn't hurt to work in anymore.
Okay, grab your flashcards because you've got to memorize this solid mnemonic for the exam. These 5 principles, popularized by Robert C. Martin, are basically your guardrails to ensure every module has a clear purpose and minimal coupling. Look, if a class is somehow handling database persistence, processing billing, and sending out email notifications, yeah, you're massively violating the single responsibility principle. If you have to dig in and edit core files every single time you add a new feature, you're breaking the open-close principle. Master these 5 concepts, and I promise you will drastically cut down on those random surprise bugs and tangled spaghetti architectures.
Now, when you're integrating testing into your workflow, you should always structure your tests in 3 distinct blocks. Never mix them up. This is the AAA pattern. You arrange your setup, you act on the method, and you assert the outcome. Keep them separate. By doing this, your tests essentially become living documentation for your code. Remember treating a feature as incomplete until these basic tests validated? That's a completely non-negotiable habit for 2025.
All right, Module 3, Managing Technical Debt Safely. We have to tackle this reality because shipping fast almost always means taking on debt.
Here's a core economic principle you need to master for the test. Coined by Ward Cunningham way back in 1992, the absolute crucial takeaway here is that taking on technical debt can speed up your development, but if you leave that interest unmanaged, it will eventually stall your entire organization. It's literally like swiping a credit card. A little debt gets your awesome product to market faster, but every single minute you spend navigating poorly designed, hacked-together code, that counts as interest. If you don't pay down the principal through refactoring, your whole engineering org will eventually just grind to a standstill under the weight of it all.
So to prevent that total standstill, teams absolutely must explicitly reserve between 15 and 25% of their development capacity strictly for paying down debt and refactoring. And guys, this isn't just a friendly suggestion. It's a hard structural requirement for sustainable software development. You've got to prioritize this based on the impact and effort, continuously practicing those micro refactorings we talked about, and making the actual state of your technical debt highly visible to your business stakeholders. No hiding it. Next up, Module 4, Collaboration and Code Reviews. Let's see how all this builds into working effectively with your peers.
According to Google's official code review standards, developers basically must be allowed to make progress. That means technical facts always overrule personal style preferences. And honestly, this is a massive paradigm shift for a lot of us. If a pull request improves the overall health of the system, just approve it. Don't hold up a vital feature release just because, you personally prefer a different subjective stylistic choice. As long as the code follows your team's style guide and sound engineering principles, progress always trumps perfection.
Make this your daily morning ritual before the real test begins. Unblock your peers before you even open your own IDE to write a single line of code. Executing quick, timely code reviews first thing in the morning completely slashes the risk of stale pull requests drifting away from the main branch. And when you do review, be candid. Stay totally detached from your own ideas, call out flaws logically, and work collectively as a team to synthesize the absolute best possible direction.
And finally, Module 5, Essential Tools and Debugging. Let's talk about the habits you need to get yourself unstuck.
We've all heard of it, right? Rubber duck debugging. It's legendary for a very good reason. Verbalizing your problem literally forces you to slow down, rethink your base assumptions, and catch weird edge cases, all without interrupting your teammates' flow. By translating your abstract, tangled logic into clear, spoken language, or, hey, even typing it out in a debug journal, you declutter your mind. 9 times out of 10, you're going to catch your own ridiculous contradiction before you have to embarrass yourself by asking a senior developer to come look at your screen.
Now listen, if there is a hidden trap on the 2025 exam, it is blindly trusting AI. You absolutely must critically review all AI-generated code. Leverage tools like GitHub Copilot, sure, but use them wisely because AI does not outsource your thinking. You have to validate the logic yourself. Couple that critical eye with small, crystal-clear Git commits, and build a habit of actively prototyping your new ideas to test their real-world constraints before you fully commit your whole team to a technical path.
Because at the end of the day, results only count when things actually get shipped to production. Getting things done is a habit. You've got to sharpen your focus, ruthlessly cut scope if you have to, and push through to the finish line. All the clean code and perfect, elegant architecture in the world means absolutely nothing if it's just sitting pretty on a staging server. Highly effective engineers know exactly how to maintain their intensity when a project nears the end, navigating that waning energy to ensure the code actually ships. So keep learning, stay curious, and please start applying these principles to your very next commit. The tech landscape in 2025 isn't just going to reward people who can type code. It's going to heavily reward those who actively cultivate these habits of excellence. Take just one principle from today's syllabus. Maybe it's the Boy Scout rule or doing your PR reviews first thing in the morning and implement it right away. Class dismissed. But I'll leave you with this. What's the very first habit you're going to change today to ensure you pass the test and actually shape the future of tech?